Hi, my name is Jason Lenard. I'm with Everyday Energy. We're based out of Carlsbad, California, North County, San Diego. Today we're on the rooftop of the American Lung Association, California, in downtown San Diego. And what we're installing today is 44 240 watt Trina modules that's going to produce 10.56 kilowatts DC. The annual production will be just over 16,000 kilowatt hours. And basically we're using 240 watt modules. We have two inverters downstairs that we'll check out in 2 seconds. But basically we have these, each module right here has two leads coming off of it. We have a positive and a negative. The positive is daisy chained over to the negative of the next module, and so on in what we call a string of modules. Now we have one string of 10 modules going down to a 4000 Sunny Boy SMA inverter, and we have 3 strings of 30 modules going down to a 7000 SMA Sunny Boy inverter. When the sun is out, it hits the solar modules, and the solar modules then produce DC direct current all the way down to the inverters I had mentioned earlier. And we can go downstairs and see exactly how the DC current is inverted into AC current, or alternating current, that goes and ties back into the utility grid. All right, now we're down on the ground level where the PV equipment is installed on the wall right here. Here's the DC risers that actually come down, bring the direct current into these inverters. The SMA 7000 right here and the 4000 right here. Here's the DC disconnect. This is one of our first means of disconnecting means. And if you could just half this disconnect right here, you have a DC side on your left-hand side, and that DC current travels up into this inverter and inverts it on the right side to AC power that we could use. So the AC power is then combined at the photovoltaic subpanel right here, and we have another disconnecting means right here by breaker, and comes over here, and this is the AC disconnect for the utility operation. So the local utility company can actually shut it off, this whole system right here on the AC side, in case of emergency or to service for future. Now we're inside the interior main distribution panel. This is the switchboard manufactured by Square D. We have taken, as you can see, we're not done terminating yet for the interconnection point. We've taken those sun's rays through the Trina modules, which produce DC current down the risers, and inverted into AC alternating current through the PV subcombining panel, through an AC utility disconnect, out into the main switchboard right here. And what we're going to do when we finally finish, we're going to end up terminating these now alternating current lines into an interconnection breaker right down yonder right here. And this whole metering situation, which you can see the meter right here, this meter is going to be swapped out from the utility company into what's called a net meter situation. And we are doing a load side tap net meter application for this solar system. And basically when the utility company goes and stabs a new net meter in for the client, all of that energy produced from the sun and inverted into alternating power will go back to the utility grid. And then after the utility company receives that power, they will now credit the client or the customer for all the power generated from the sun through the solar modules.